Let's talk about constant acceleration. Acceleration is a trickier concept than speed. It tends to be that humans can naturally recognize when an object's going fast or slow, and even in general if it's maintaining a constant speed. But acceleration is a little bit tougher to tell and a little bit more counterintuitive when you're trying to look at it in different representations. So, one of the first things that I want to emphasize is this text that's on the screen right now. Acceleration is not the same thing as speed. Acceleration does not tell us about the motion of the object. That's what velocity and speed do. Velocity tells you how fast you're going. That's the same thing as speed, and it tells you which direction you're going. So if you have a small positive velocity, you're going slowly in the positive direction. If you have a very, very negative, large velocity, then we know that you're going quickly in the opposite direction to what we've defined as positive. Acceleration tells us something different. Acceleration tells us how much that speed is changing. And you have to be careful because a positive, unlike velocity, where positive always means this direction and negative always means going the opposite way, acceleration is a little bit trickier because it doesn't mean speeding up or slowing down. It tells us what direction the velocity is changing in. So if you know acceleration, you don't know anything about the motion. What you know, if you already know the motion, is how it's going to change, what's going to be happening later, which is still very useful, but a more challenging concept to wrap your head around. So to start getting us used to thinking about the signs of position, velocity, and acceleration, I have this really fun game called positive, negative, or zero. And what we're going to do is we're going to look at these 5 different cases and decide whether for A, B, C, D, and E, whether the position, velocity, and acceleration are positive, negative, or zero. That's the name. So looking at the first case, this is an object that if you look at the motion diagram that I drew here, has a constant velocity. Our next one is an object that's speeding up. V1, the first speed shown, is less than V2, the second speed. Then we have an object that's slowing down. V1 is greater than V2. And then we flip over and we have somebody who's running the other direction. And they're going, in this one, they're speeding up because V1 is less than V2. And in the final case, V1 is greater than V2, which means they're slowing down. I've set up a coordinate system because you always need a reference frame when you're going to start defining whether things are positive, negative, or zero. So I said 0 is like between all of these runners, between the people on the negative side and on the positive side. Anything on this side, vectors going this direction or positions on this side is negative, and anything on the right side is positive. So now that I've explained the whole scenario, I would suggest that you try to pause the video and see what you can figure out on your own. I'm sure you just did a great job. Let's double check your answers. So going through here, I guess I'll do it in green. I haven't used green, that's fun. For A is right on the line, so their displacement vector is 0, because if I measured how far they are from the reference point of 0, they're at 0. Their velocity, they're still going in the positive direction, so they would have a positive velocity because their vector for the velocity is going to the right. Their acceleration, though, that's a plus, by the way, not an x. Their acceleration is 0 because it's a constant speed. Going down to B, this person is right here on the negative side. So if I was drawing a displacement vector that measured where our 0 point is to where they are, that would be going in the negative direction. But their velocity is in the positive direction. So that's going to be positive. And they're speeding up, which means that if I add, what I have to do is add to their vector. So I have to take this plus this to get an even bigger vector so that they're consistently speeding up, which would be positive. Then for C, C is here on the positive side. We know that they're still going in the positive direction, but their vector is going to be getting smaller, so they have a negative acceleration. They were going this way, or like a big vector. Then they had a smaller vector, which means we took some velocity away. And since our acceleration is pointing in the negative direction, we have a negative acceleration. For D is over here, once again, on the positive side. But the velocity vector is going in the negative direction. So we have our first negative velocity vector. And again, for velocity vectors, that tells us the direction of the motion and the speed of the motion. So since the direction of the arrow is negative, we know the velocity must be negative as well. But the acceleration here is where it gets a little bit tricky, because we have a little vector and then we have a bigger vector. That means that we had to add something to this first vector to make it get bigger. So if we look at this added vector and the direction of the added vector, we notice that it's going in the negative direction. This is a common error that students assume that you have to have positive acceleration to speed up. That's not how it works. You have to have acceleration going the same direction as your velocity to speed up. So you'll notice that both B and D had velocities and accelerations in the same direction, and they both sped up. Then finally for E, we have a big vector going to a smaller vector, which means we have to take some away. And look at that vector that I just drew. It's pointing in the positive direction, which tells us that it's slowing down because we know the velocity vector. If I told you somebody had a positive acceleration, if we only had this column to go off of, we could not describe what these people are doing. With the velocity column, we can describe what they're doing. And with the position column, we can describe where they are. But each one tells us different information, and you can't tell where somebody is if you know their velocity, just like you can't tell what somebody's doing if you know their acceleration. Their velocity helps tell you where they will be. Your acceleration helps tell you what their velocity will be, what their motion will be. I still need to finish filling in E. That should be negative for the position, and it's going in the negative direction for the velocity. Okay, so that hopefully introduces a little bit about the signs for acceleration, and then we'll talk about some motion diagrams in the next video.